Hello and welcome back to SCI Teach. This is a physics practical lesson on buoyancy. So what's buoyancy? Buoyancy is a tendency of an object to float in a fluid. A fluid is either liquid or gas. Now all fluids and gases, or all liquids and gases, in the presence of gravity will exert an upward force, and that's what we call buoyant force. It exerts this buoyant force on any object that is dipped in that liquid or gas, immersed in the liquid or gas, so immersed in the fluid. So buoyancy is as a result of the differences in the pressure that acts on the opposite sides of any object that is immersed in a fluid. So the buoyant force is the upward force exerted on an object that is completely or partially immersed in a fluid. Now, this upward force is also called upthrust, so you can call it upthrust. And due to this upthrust or this buoyant force, a body that is submerged completely or partially in a fluid will appear to lose its weight. It appears to be lighter. Now, density is a very important factor that affects buoyancy. What I'm saying is, an object whose density is greater than the density of the fluid in which it is submerged, that object will sink. But if the object is less dense than the fluid, at the density of the fluid, then that object will float. All right? If I want to speak in terms of relative density, and I will say that if relative density is less than 1, the body will float in water. And substances that have relative density is greater than 1 will sink in water. Okay. So when an object is immersed in water or any other fluid, we observe that the object experiences a force from the downward direction opposite the gravitational pull, and which is responsible for the decrease in the weight of the body. And this upward force exerted by the fluid opposes the weight of the object that is immersed in the fluid. So buoyancy or upthrust makes it possible for swimmers, fishes, ships to float. All right. It is the reason why if you jump into a swimming pool, you don't sink, you float, so you swim easily. It's also the reason why ships don't sink, though technically, ship is shaped such a way that to manipulate the densities so that it can float. But upthrust or buoyancy is a major decider in why it floats. Now, because we said fluids are liquids and gases, so let's not just use liquids as examples. If you fill a balloon with hydrogen or hot air, now that balloon rises in air because the density of the air or the hydrogen inside that balloon is less dense, it's less than the air surrounding air. So the balloon on the hydrogen inside the balloon makes the balloon rise up. So that's also buoyancy, and a classic example of how density is a major factor in buoyancy. Now, Archimedes Principle is why we study buoyancy. Archimedes Principle states that any object that is wholly, like completely, or partially submerged in a fluid experiences an upward force that is equal to the weight of the fluid displaced by the object. Okay? That is to say, if you put in any object, whether it's completely inside the water or liquid, or it's partially inside the liquid or fluid, that body, that object, will experience an upward force. And this upward force is equal to the amount of the measure of the amount of liquid or fluid that is displaced as a result of that object entering into that fluid. That's Archimedes' principle. Now, this is a practical lesson, so let's practically analyze buoyancy. We're going to set up an apparatus as shown. We're going to attach a spring balance to a retort stand, a clamp stand, as I'm showing now, and then attach a mass, say a mass of 50 grams to the other end of the spring balance, and then let it immerse into water that is in a beaker. Then we do the same setup in another clamp stand, spring balance, attach a mass, still 50 grams, but this time we use a beaker filled with another liquid, not water. In this case, let's say we use kerosene. So on one beaker we have water, on another beaker we have kerosene, and the setup arranged like I'm showing you now. The spring balance, the mass is same weight, 50 grams each. Okay, now before we even put the masses in the liquids, the two different fluids, we're going to weigh use the spring balance and check the mass of the or the weight of the 50-gram weight. Check it in air before immersing in water or the liquids, and then we immerse them. So we immerse them and determine the weight of the object when it is completely immersed in water in one beaker, and then record the weight as W2. W1 is the weight of the object in air before we immersed it. We measure it, then record the weight of that one as W1. Then immerse it in the liquid, the water now, and then record the weight as W2. The weight will be shown on the spring balance. Now we also determine the weight of the object when it's completely immersed in the kerosene now, and record that one as W3. So W1 is the weight of the 50-gram weight in air, then W2 is the weight of this same object when it is immersed completely in water, then W3 is the weight of this same object when it's completely immersed in kerosene. Okay, we do that for the 50-gram weight. Then we change the weight, the grammage, and put in 100-gram weight. Repeat the same process. Then we put a 150-gram weight, repeat the same process, put a 200-gram weight, repeat the same process, and then put a 250-gram weight and repeat the same process. Then we calculate W1 minus W2 for each of the weights, for each of 50 grams, 100 grams, 150 grams, 200 grams, and 250 grams. Calculate W1 minus W2 for each of them and call the answer U for each of them. And then calculate also W1 minus W3 for each of them and call the answers V. Okay? And then we tabulate our readings. That's to say, we form a table of that has W1, W2, W3, U, and V. So we fill in all the values under that table, and then we use it to plot a graph of V on the vertical axis and U on the horizontal axis. We do that, and then we determine the slope of the graph. All right, and of course take the precautions that we have to take to ensure accurate results. Of course, the precautions are to, number one, avoid parallax error when you are reading your spring balance. Number two, avoid or note zero error of the spring balance. And then number three, avoid splashing of the liquid. Okay, and then avoid objects touching the bottom of this or the sides of the beaker. Let it just be immersed in the liquid. Let it not touch the sides of the beaker or the bottom of the beaker. And clean the masses before you dip it into the liquid. Okay, those are the procedures you must take to ensure that the practical is done correctly. We will do the practical in another video and post, but you have to follow this process and use it to prepare and get ready for any question that will come out of it.